Vegas at 4:45. It's actually moving pretty good right now. Man, this place really does feel like LA. Didn't used to always be like this. People have short memories, or you know what I mean. Things change slow enough to where people don't really perceive what's really going on here. This town, well, you know, we have precedents for it. We have New York City, we have LA. So it's not like it's new. It's just in the Vegas for a long time was like I don't know what our current population is, to be honest with you, but it was a lot less crowded. And this is at 4:45. I got up really early. I headed to work at like 6 a.m. So, well, actually, like I got up at 6. I headed at like 7. So I decided to leave work early today, thinking I'm gonna get better traffic, and actually I am. 5:30. Vegas is interesting because we're open 24 hours, or at least a portion of us is open 24 hours. So we have the day shift, the swing shift, and the graveyard shift. So people are getting off, and even like the day shift, we have so many hospitality workers that a lot of us, we either go 7 to 3, 8 to 4, or 9 to 5. Maybe more people do that these days, but in Vegas, it seems to be a little bit different that way. So it staggers the traffic, but even with that, in one hour from now or 45 minutes from now, it'll be like it is on the other side. You see the other side? It's almost standstill. These are people that work on the east side or the south side of Vegas, or Henderson, or Boulder City. A lot of people are commuting these days, but anyway, these are people that they work out there, but they live closer into town. I'm heading southeast toward Henderson right now. That's Black Mountain in the distance. Famous right below that is Pepcon, where Pepcon used to be. So in 1980 something, 84 maybe, Pepcon exploded. There's some really famous footage from the top of Black Mountain over there, way over on the left there. You see how busy the 215 is? This is the Beltway. This goes, well, actually, I don't know how they call it these days, but this is the new freeway. Yeah, we're moving right along. There's a full moon rising. Wow! Full moon rising. It's not dark yet, but you can see it. Right there, like kind of due east. Yeah. The world, a lot of people know this, but some people don't, but the world spins. Some people think the world's flat. They're absolutely out of their minds. It doesn't work that way. You're being propagandized. Someone said it's a psyop, but I could sit down and talk to you about the science and show you where they're manipulating you. But so the Earth spins to the east. So that's why all the stars and even the moon sometimes, depending on where its position is around us. But in the case today, on February 22nd, 2024, it's rising right on the east, and that's the way we spin. So that's why everything rises in the east, because we're spinning. The things we see are relatively stationary. The moon's moving pretty fast around us, but relative to us, you know, one night, it's you know, it's imperceivable, really. So all the things that we see in the horizon are relatively stationary. The moon less so. The sun very much less so. The sun is basically stationary. The stars are basically stationary, but the sun is actually more stationary than the stars because we, the Earth, orbit around it. We are the sun, despite what they say. I mean, I'm just talking about the flat earthers, but the sun spirals. I'm sorry, take that back. That too, but the Earth spirals through the universe, through the galaxy. The Earth spirals through the galaxy. Why? Because we're following the sun, and we're orbiting the sun while the sun is on its own trajectory around the galaxy. So now, see, now we're facing east. We're going east. You can see Black Mountain like kind of center screen, and Pepcon was like right in front of us, up further up there. And you can see the moon there in the left-hand part of the screen. So yes, that is spiraling around us. And the people that say things like, oh, we'd be sucked into the sun's gravity, and they just don't understand. Or they're manipulating you. For what reason, I can only guess. But that sun, or that moon right there, is rising because we're spinning toward it. And to my left is south, or to my left is north, to my right is south. So basically the top of the globe, I'm in Las Vegas, Henderson, the top of the globe is to the left. If we were in a classroom right now, our car would be going sideways. We were on a classroom globe. Some of you guys know what I mean by that, you know, a spinning globe. And we'd be kind of on the side of it. Imagine just take a little race car and kind of get your globe and put it on Nevada. That's what it would be like. And then, and people who they don't understand magnetic density. They also don't take, or maybe the ones I've heard, they don't take into account that that we're traveling quickly through space. And when they say things like, oh, we're going so fast through space, how come nothing's moved? It has. It's just basically imperceivable to us. You don't realize how far it is. I mean, we think of the fastest thing you've ever been on. The fastest thing you've ever been on. The fastest thing I've ever been on traveled just under the speed of sound. It was a big, huge jumbo jet. We were going like 690 miles an hour or something like that. It was crazy. Since then, I've noticed that airspeeds aren't as much. But anyway, just imagine it's the fastest thing you've ever been on. And if you, according to what they understand the speed of light to be, and the speed of light, people don't realize it's 186,000 miles per second, I guess, here on Earth, based on like I think it's Whitehead's experiments. And I believe that, but the light has to go through magnetic density, and the Earth has a certain magnetic density. That's why everything falls at the same speed. And so light, let's see, wait, where am I going with light? No, the Earth has that magnet. So when light goes through it, yeah, okay, the measurements, that's awesome that we can figure that out. 186,000 miles per second or so. But realize when light goes away from the magnetic density, it will speed up as it moves outside of its magnetic density. That's the nature of light. And so, anyway, but so there's a lot of things that the flat earthers do to manipulate people. They quote a lot of things. And what I was going to say about that, and I'm not trying to attack anybody. I mean, I get everybody's trying to figure it out. I get that. I'm just sharing my best guess, my belief, and to some it will make sense. But so at least these stars, if this parallax thing works, let's say that it's true that Sirius, the dog star, the one that rises in the southeast and is in the eastern sky during the winter, you can see it now. But that's the closest star to us. It's also the brightest to our visual eye, but that is called Sirius. It's only about 9 light years away, they say. But it's even further than that, because as the light leaves the Earth, it speeds up. And that's something that's not conventional, but it's what I believe. And so, so even like Sirius, that jumbo jet that I rode on that was going just under the speed of sound, it would take millions of years to get there. Millions. And I could go into how you can kind of figure that out, but it's pretty easy math. And so when they say things, they either are in a linear thinking. A lot of people are linear thinkers. What does that mean? Does that mean they're stupid? No. Some of them are very smart, but they are smart in that they can tell you what they've learned. It's hard for them to think outside of their box. It's hard for them to triangulate their language. This is for the geeks out there. It's hard for them to triangulate their language because they are linear thinkers. They think in the subjective and the objective at best. I'll just leave that there for now, but so the moon, now right now we're heading toward the B mountain. These are the Black Mountains, and there's a big B on there. And some people that don't, you know, that come here for the first time, they don't know that that big B stands for basic, which was originally Basic Magnesium Incorporated, BMI. It was a magnesium company here in town. The first, you know, Tymet. And that Tymet is right next to Pepcon that exploded, which we're getting close to where Pepcon used to be. Black Mountain is to my south right now, to the right. North is to the left. We're going due east now. You can see the moon rising. It's rising because we're spinning to the east. Gibson Road coming up. Pepcon was just basically to my left. Just basically to the north right here. We're passing kind of where the big explosion, and you can see to the right, you can see Black Mountain. And that's where they took that footage. Let's see there, good. To my left, you can, well, I don't want to get in a wreck or anything. You can see Sunrise Mountain, really pretty right now. Such a pretty mountain. It's really called Frenchman Mountain. We call it Sunrise. That's like our nickname for it here. But it's Frenchman Mountain. And then the Sheep, I think they call the Sheep Mountains to the due north, or like, you know, northwest. And of course Mount Charleston is to the west, northwest. This is kind of the beltway. This guy needs to get over. Go ahead, brother. I just need to get over too. I check my wide view mirror first. I've been trained. I trained myself. Always check your wide view mirror first. That way you kind of got your blind spot covered. And then check your normal mirror, especially if you're towing something. Tesla. I bet you that lady paid 90 grand for that car. She feels so good in that car, or him. They should, it's awesome. There's Black Mountain right there. To the left there. Or to the right. I'm really bad with left and right. To the right, sorry. I've always been bad at that. It's so funny. Oh man, look at that girl just sporting around in her little Tesla. That's an expensive one too, I bet. I'm not really that knowledgeable about cars, so some people know that. right now we're going south. So this is, we're going down the globe. Down. If we're on a globe in your classroom with a car, you'd be driving down the globe to the bottom part. And that's how we are a globe, and we're not flat, we're a globe, and we're spinning toward the east, toward my left. I don't know why that's so hard for me. It's crazy. And this is like this is heading toward Boulder City. It's heading toward, you know, Searchlight, Needles, that part of the Mojave Desert. Las Vegas Valley is actually so awesome. Oh, it's been such a great place to live. It's kind of a little crazy now. Just our population is booming. That could be a good thing, but it could be a bad thing too. Not because all people aren't awesome. They are. Even the mean ones, they just are sad or scared. Had bad teachers, that's all. If they would have been loved, nurtured real good, don't let it fool you. Don't let them fool you. They may have kind of gone dark. They may be dangerous, I believe that, but they still are only that way because they were mistreated. They would rather be loving because it's actually much more satisfying. But when life sucks, it's satisfying to be angry and violent too. That's why they choose that, but it's more satisfying. How do I know that? It's just what I believe. It's my best guess. The reason is it actually has physics behind it too. I'll just say it real quick. Not everybody knows this, and they would argue, but I'm just telling you my best guess, which is my belief. Is that, let me just drive here for a minute. I actually didn't mean to get off this freeway. I don't know why I got off. Usually I would just take that all the way around to Wagon Wheel. But the good thing is I could get me some lunch or some dinner. Because I don't want to put anything in my microwave, or I don't want to cook anything tonight. To clean dishes. So far, all these restaurants are still open. There's that Ford, or that Tesla. Ooh, she's so happy. Now we're going east again, so you can see the moon rising. Again, it's rising. Sorry I'm repeating myself, but it's rising because we're spinning toward it. And we're also, just like it's orbiting around us, although we won't be able to really perceive the change in space tonight. Tomorrow night, next night, it'll be in a different spot. But in one night, the movement that we see is mainly us spinning, our globe spinning eastward. That's what's going on right now. Why doesn't it just fall into us? Because it's moving in a helical. That's what's going on right now. Everything's in a helical. You can look that up. We're spiraling around the sun, and the reason why we're not getting sucked into it is because there's two forces. There's the force of our planet moving forward, and then the flux that's created by the force of the gravity. And that's what keeps us in a constant spin. And basically, when it comes to intelligent light and the true anatomy of an atom, when we are good to each other, when we choose goodness, back to what I was saying earlier, our intelligent light, just so you know basically what I'm saying here is, the true anatomy of an atom is a bundle of magnetic field particles. We can talk about exactly what that is, but just think of the smallest quark you can think of. A bundle of those, the magnetic ones, the dark ones, with electric field particles, the second of three elements in the universe. The first is magnetic field particles. That's the first element. The second element of three is electric field particles, the smallest quark of a particle that's electric. And then the third thing is intelligent field particles. And maybe these are just like a different form of the electric ones. That part I don't know. But those electric field particles spiral around a bundle of magnetic field particles. That's the true anatomy of an atom. If you can imagine that, make a fist, call that the bundle of magnetic field particles, and now, I guess with the tip of your finger, go around and around and around your fist. The tip of your finger is a bundle of electric field particles, electric and intelligent field particles. And the bundle that's relatively stationary is the bundle of magnetic density field particles. I mean, that's the true anatomy of an atom, and everything kind of follows that. So creation and time, everybody tries to figure out what time is. They have their theories on what time, what is time, like the fourth dimension or whatever. Time is simply this. As soon as a true photon, a light, okay, just as soon as a bundle of electric field particles that spiral through magnetic density, a bundle of electric field particles spiraling through magnetic density, as soon as they, instead of spiraling through it, they orbit around it, as soon as their forward trajectory is countered by the magnetic density of a bundled magnetic field particles, and it starts to actually orbit it instead of just curving through it. Light will curve, but it's not because the universe is curved, it's because it's curving when it goes closer to big bundles of magnetic density. So if a light photon is going through space and there's not any planets nearby, it's going to go relatively straight. But as soon as it passes a planet or a sun, it's going to start curving, because what a light photon is, it's a bundle of electric field particles that are spiraling through the magnetic density as a medium. But once it curves so much that it orbits a large bundle of magnetic density, or however that kind of forms or comes about, then you have time. Time starts there. And time is relative to every system. Time is relative to our solar system. We measure time based on how many times we spin, how many times we see the sun, then we don't see the sun, we see the sun, then we don't see the sun. And we measure it by how many times that moon up there orbits around us. So it's different that way. But the minute a bundle of electric field particles that are spiraling through the magnetic density of space, instead of just bending around strong magnetic density, they start orbiting it, spiraling through it and bending, but then they start orbiting it. That's when time starts. That's time. And the bundle of electric field particles will ultimately, their orbit will decay. Just like if the light photon would have kept going through space, at some point the magnetic density, the medium, dissolves that light, sifts that light away, sifts one little electric field particle at a time. This bundle of electric field particles that are spiraling electric field particles of that bundle get sloughed off as it moves through space. So it can only last so long, and a light photon at some point is gonna die away. Its longevity depends on how intense the light is, how tight the spiral is, and at what speed, and the mass of the bundle of electric field particles. So there's several things that are involved, but over time, the magnetic density, the medium that it's spiraling through, this light photon, the true light photon is spiraling through, when it starts orbiting around, it's also going to its orbit is going to decay. The bundle of magnetic field particles that light photon started to orbit, instead of spiral through the density it's orbiting it, it is also dragging it inward, just like the sun is dragging the earth inward, and the earth is dragging the moon inward. But it's very, very slight. The moon's its regular trajectory that it was going on, whatever mass it was at the time, when it got caught in the magnetic density of this planet, it started orbiting it. And then we have flux, which is basically just the forward motion and countered by the gravitational force, which is gravity is is magnetic density. That's what gravity is, magnetism. Despite what anybody says, that's what it is. And the reason why the two different weights dropped off the Tower of Pisa with Galileo at the same exact time is because even though the magnetic density of each of those two objects was different, could have been 3 times what the one was, or 10 times, or 100 times, it was still you couldn't even, let's see, what's the word? It didn't even matter, because the magnetic density of the biggest ball of the 3, there were actually 3 balls that were dropped when Galileo dropped 2. They all had magnetic density, and the Earth had the most. And so that's why there's no real difference. It's because we're nothing. A car or a golf ball, it's going to basically drop at the exact same speed minus wind resistance, which is going to be minimal. If you dropped a golf ball and a car, off the Grand Canyon and exactly dropped them at the exact same time, they're going to land about the same time. The golf ball a little bit sooner because it has less, what do you call it? Less wind resistance, or resistance, but not that much. Why? Because the gravitational force, which is the magnetic density of the Earth, is bigger than the other two. Right now the sun's setting, and remember, all we're doing is it's relatively stationary. It's moving really fast around the galaxy, but to us, it's relatively stationary. We're the one that's spinning. The difference of it in space is imperceivable to us day to day. So when we see that sun setting over there, we're just this big ball that is actually spinning toward the east, which is now to my right. I'm going north now. That's the top of the globe. That's the top of the globe right there. Turn your car around on your globe in your classroom and head upward. That's the way we're going right now. And the reason why the sun is to my left, which is to the west, is because we're spinning east relative to the sun. So it's that easy, I mean, honestly, a lot of good happens when we have universities and things, but a lot of bad too, because when people start having to write papers and come up with things, they will latch on to any crazy idea. And then they make it more and more complicated, so you have to spend more money to learn more of how complicated it is. That's why relativity theory that came out of Einstein trying to kind of work with Whitehead and Faraday and all their experiments, it was, you know, it was genius. But the final conclusion was wrong. And how do we know that? Because the true anatomy of the photon and the true anatomy of the atom were easily explained in just a half hour. You know, our tissues and our cells and our organs and all these things were made up of just light and magnetic density. And in addition to the electric field particles that orbit the bundles of magnetic density, which is the true atom, in addition to that, or as part of that, the electric field particles, there's also intelligent field particles. And the intelligent field particles are our spirit. That's our soul. How do you know that? I mean, I'm just telling you my best guess, which is my belief, which is what Jesus told me. You can ask him. I'm guessing he'll tell you the same thing, but you might have to do a little bit of study. But think about how hard that is. If you're a professor that's made your entire living, the reason why your wife even likes you is because everybody says your idea is really so cool. What? You're gonna be like, oh, I was wrong? No, you're gonna fight it. There's a whole industry. You have to remember, people are by nature afraid. It's our worst quality, because if we could get over that, we could get over a lot of things. But people are by nature afraid. So so it's best. Let's see, what am I trying to say? Well, I lost my train of thought there. But there's a lot going on. So right now we're you could probably still tell we're basically going north, going up on the globe, and to the left there is the west. And you can see out there in the clouded mountains there, that's Mount Charleston. From Henderson, where I grew up, that's to the southwest. And you can see Frenchman Mountain, and the Sheep Mountains past those, and then Mount Charleston. Look how pretty. Mount Charleston is kind of that's like the Las Vegas mountain. That's the one that we're all, that's like the granddaddy mountain of them all. Sheep Mountain's second, but it's kind of so far away we don't see it much. The B here in the River Mountains, that B stands for basic. I was saying that. The Q below it stands for Quentin Robbins, and he's the son of Jody or Joe and Tracy Robbins. And he's just a beautiful young man, beautiful. Everybody liked him. He was a coach. He was worked at the rec center. He played sports. His dad was an awesome athlete. His mom was totally beautiful and awesome. And he was shot by some madman or some government psyop or whatever it was. He was shot by some idiot. Took his life, and he was loved, so loved that the entire community said, screw it, man, we're not getting a permit, we're painting a big Q on the mountain, and the people who are in charge of leadership can just deal with it. And I guess they did. And people are remembering Quentin, remembering what happened. You can think a little bit about why stuff like that happens, and what's the best way to fix it. So I actually, if anyone's actually listening to this, I just think that's so cool that you would listen this long. Maybe it was kind of interesting too. But And maybe if you were thinking about flat Earth and wondering a little bit about Einstein and just about, you know, things like that, you can kind of ask Jesus if he'll tell you the same thing. If the true anatomy of a photon is what I said, and if a true anatomy of the atom is what I said, which is easy to say, I'll say it again just so it's so easy. The true anatomy of a photon is bundles of electric field particles and intelligent field particles that spiral through magnetic density, through space. Space is actually whatever the part that is in between each of the that are in between each of the magnetic and electric field particles that out in what's known as like outer space. That is kind of a mixture of both. The only time we see light is when bundles of electric field particles spiral through magnetic density. Then that's when we see light. Well, how does light happen? You know, that's another topic too. Combustion and, you know, God. And and then the atom is just when that light, but when, you know, and so that's maybe why some people, you know, misunderstood and thought that space was bent. No, it's because light actually bends around magnetic density. Gravity is just magnetic density. And what is the true anatomy of a photon? Or I mean an atom? It's just a bundle of magnetic density that has electric field particles and intelligent field particles that, instead of spiraling through space, start orbiting around it. And that's when time starts. Ooh, I'm gonna go to Kentucky Fried Chicken. And if you're still with me, you are crazy. But oh man, the moon's looking brighter and brighter because it's you know, hitting more and more direct sunlight. And again, the reason why the moon isn't being pulled into the sun is because we're moving. Right now, the magnetic density of the Earth is creating a system between the Earth and the moon. It was moving forward, then it got caught in our magnetic density and starts moving around. So those two forces, and because of kind of the vacuum of space out there where the magnetic density is less, allows it to keep going, but it does decay. Typically, that's how at least the atom decays. The light, the electric field particles that are going around the bundle of magnetic field particles, the dark, ultimately that orbit decays, and that's kind of the pool of sin. That's when we want to do things that are mean and wrong, and you know, that's when our intelligent light, our soul, decays. But our soul can actually expand when we choose the right things.
Welcome to KFC. How may I help you?
Oh, how are you guys doing today? You know what I was thinking I wanted? Don't you guys have like a 3-piece, we call it like a 3 or a 4-piece wings?
We have a 3-piece full wing meal.
Oh yeah, I think that's the one. And what does it come with?
One side, drink and a biscuit.
Oh, that sounds great. I'll have the potatoes and gravy, mashed potatoes and gravy. And if you could throw in some honey and butter with the biscuit, that'd be awesome.
All right. Was that all for you today?
And then I'll have, for my drink...
Oh, I'm sorry.
Oh, no, it's okay. It's okay. For my drink, I'll have Pepsi, please.
All right. Perfect.
And that's it.
All right.
Thank you.
Would you like to round up your change for the MPA Foundation today?
Not this time.
All right. We'll have your total for you at the second window. Thank you.
Thank you. Oh my my gosh, if someone is still actually watching this, that's so crazy. But I am gonna finish. So this is gonna be, just like it said, it's on the title. It's a 45-minute show. But or less than 45-minute show. But that was just a really fun little look at Vegas and Henderson, maybe a little bit, maybe some perspectives to think about. Maybe flat Earth people can kind of think about that. I think when people ask why, like why then? Why is someone lying? Why is someone trying to, I don't know. I feel like what darkness tends to do is it sifts things. And so in our situation, I would think anything that's trying to divide us, it's basically, that's how we see it projected in these complex systems with lots and lots and lots and lots and lots of atoms. But when we do things together, when we, I like to say it this way, when we build together without flux or fear, so when we do things together without control and manipulation and all that stuff, it's really just everyone's equal and everyone's respected and loved and figured and patient, and just everybody's really trying their best, but nobody's like over somebody else. When we build things together like that, cooperatively, consensually, that's when our intelligent light actually does the opposite of decaying. Our intelligent light does the opposite of a decaying orbit. It actually expands, it brightens, it speeds up, it intensifies. Maybe it even attracts other electric field particles from space. I don't know exactly how that part works, but I know what the true anatomy of a photon and what a true anatomy of an atom is, or at least I believe it. A lot of people love their Vegas nights here. A lot of people love their Vegas nights. They got a sweet logo. You can see the V in there. They did good the very first year, went to the Stanley Cup. Have done well every other season too, pretty much. Yeah, Vegas was really happy to get the Knights. Happy to get the Raiders too. Really happy. I don't really follow sports as much, but I always liked the Raiders. I actually went to their training camp when I was a little kid. I still feel bad about stealing some stickers. $8? $8?
Yeah.
Yeah, I stole some stickers once from their training camp. It was just like an office sticker. But thank you. Here's one for you. I know it's not a lot, but
Thank you.
Maybe it adds up. Thank you.
You're welcome.
Oh, phew! I almost left without my food.
Here you go.
All right, have a good day.
Thank you, you too.
All right. Well, I'm gonna sign off, but I hope that was instructive. I hope you enjoyed it if you're still listening to it. And if you ever have any thoughts or questions, just contact me. And if not, mock me. I just say that because, in the social media culture, it seems like the easy, it's definitely the easy road. It's definitely the low road. A lot of people don't do it, but some people do. They mock instead of discuss and try to be curious. It's like that football coach in England show. I can't remember his name right now, but he said, "Be curious."